Hello, everybody. I hope your week's off to a good start. Welcome back to Lecture 8, where we're going to talk about images. We've talked about a lot of things so far in this class, but one thing that I think may have been rather conspicuously missing was a discussion of how to move files around. It's quite likely that you might at some point want to write a backend that will handle images, and how do we actually deal with that? So let's talk a little bit about how we store data, how we've been storing data so far. Um, we've been storing data in SQL tables, which are great. Here's an inventory table for perhaps a grocery store. Um, we can store IDs, names, quantities, and prices for different fruits. And these columns all have types. We're storing our IDs are integers. The names are text. The quantities are integers. The prices are real numbers. So it makes a lot of sense. But let's say we wanted to add an image to this table. We wanted these cute little images of an apple, an orange, and a banana. How would we store those? So there are three different main ways that we could store images. We could store the images as the blob type in the database. We can store the images as a local file path in the database, or we can store a URL for the image in the database. So let's look first at storing blobs. So a blob of data is stored exactly as you input it. It is a binary large object. That's what it stands for. And it's literally just directly the binary data you give it, the contents of a file, the pixels of an image, whatever you put in there just goes in there. So it's a way to store basically anything. It does not care what you put into it. You put it in, and it means nothing, and you can take it out, and hopefully it's meaningful to you still when you take it out. So, for example, if you were to go into your terminal and use cat to try and print out some complicated binary file, a PDF, or an image, you might see something like this as the raw bytes are forced and coerced into being some kind of string encoding, like ASCII or Unicode, and you'll get this garbage. But to certain programs, this has meaning, like to an image renderer, this might mean something. So, storing blobs are somewhat unideal though, because database storage is relatively expensive. This is highly optimized, very fast stuff, and we don't really need that for our images. Databases are designed for structured data, so you can do all kinds of fancy selects and joins with all your integer and string columns, but a blob doesn't really mean anything to a database. So you you can't select on a blob. You can't join on a blob because a blob, as far as the database is concerned, isn't really anything. The database knows nothing about the concept of what an image is or how it would consider an image. How would it check a condition of an image? It doesn't know. And then also, because blobs tend to be large, we're putting in big images and stuff like that. Backing up your database becomes slow because you suddenly have a lot more data than you did before to shuffle around. So our second method that we could explore is storing file paths. So it's important to remember for this, servers are computers, which means that your code and database are not everything that there is. Images are files, and computers have file systems. So if you are given if you're given a file, you can just write it to the disk on the computer that your server is running on, in some certain folder that you specify, And then you can just store those paths in the database. So, you might have an images directory alongside your source directory, just in the root directory, and you might write the images that you're given into that directory, and then in your database specify an image path, just some text that tells you where to go look for the actual image. And then suddenly your database is a lot smaller and faster again. So using file paths, we can avoid the slowness that comes with storing such large objects in our database. We can get better scalability out of our file stores. Since we are directly reading images from disk and writing images to disk, we don't need to do any kind of conversions or anything. It's just a direct image on disk to image sent or image received to image on disk. No conversion or special handling necessary. The image backup is also kind of asynchronous because our images are stored completely independently of the database. We can operate on both at the same time. And it's just a little prettier and cleaner. However, there is another option, which is hosting files from a different source. You may not want to store large volumes of images locally. Specifically, if you're planning to have your server be very scalable, if you spin up a second identical server and you're writing to local disk, suddenly all of your images uploaded to one server are inaccessible from the other server. Whereas a database, of course, the two would ideally share. You also, if a server crashes, you don't want to put the files in jeopardy. And honestly, you may want to just separate responsibilities. Tight coupling is generally considered bad software practice. So loosening that coupling and moving your files elsewhere so they're not quite so tightly interwoven with a specific server instance. It just makes things a lot easier to work with and resilient. More resilient. So you can use several cloud-based storage solutions for this. There's lots of free and paid services that offer remote file storage. Big ones include Amazon S3, Microsoft Azure Blob Storage, and Google Cloud Storage. So these, much like other cloud services that we've talked about before, these are much smarter people than me, at least, figuring out what needs to happen. So they handle backups, they handle replication, data availability, security. All you have to do is give them a file, and there's some authentication and credentials for security, but what it boils down to is you give them a file, and they give you a URL, and you can keep that URL, and whenever you want your file, you can use that URL to get that file back. And now, suddenly, your data is completely safe and in good hands, the hands of professionals that know how to make robust software. And you don't have to worry about that. It's a solved problem. Your servers can focus on the functionality that they need. So anyway, that's all for this week's lecture. In the demo, we're going to Rahi's going to take you through storing and retrieving images in Amazon S3, using base64 encoding to send images, and how to retrieve images from Amazon S3. However, it's important to keep in mind there are a lot of alternatives. There are a lot of ways you can do this. One thing I'll also mention is Amazon actually offers elastic file systems where you can create a shared file system and have a simulated file system that actually exists external to any of your servers and that all of them can share. There's a lot of pretty cool stuff out there. Anyway, I hope that you enjoyed this lecture. I hope you found it informative. There's no assignment this week again, but I hope you're getting excited for the hack challenge. As always, if you have any questions, want to talk about any kind of CS backend stuff, feel free to reach out on Slack, come to office hours. We're friendly. Yeah, so have a great week.